Welcome. This is the regression analysis course. My name is Nicoleta Serban. I'm an associate professor in the School of Industrial System Engineering. The topic of this lesson is parameter estimation with data example. We'll learn using R how to implement a multiple linear regression model in R and how to interpret it. Let's return to the example. We're interested in the relationship between advertisement expenditure and sales. And again, this is a set of predictive variables divided into quantitative and qualitative predicting variables. This is a set of questions we may be interested to address in such example. We like to first fit a linear regression with all predictors and estimate the regression coefficients. Also, we would like to interpret the coefficients and compare for particular predictors the estimated coefficients from the conditional model versus the marginal model. Particular here, because we already studied this example for under simple linear regression, we want to see the estimated regression coefficient for advertisement expenditure variable under the conditional and the marginal model. We want to see the interpretation and how those two models will predict differently sales. And we like to see whether which of the predictions are more meaningful. And of course, we want to also compare the estimated error variance under the conditional versus the marginal model. This is the starting point of doing a data analysis. We read the data in R, then we extract the predictors or the variables of interest that we'll study in this example. Here, because this data set does not have a header, we're actually providing names of the columns in the data, according to the names that we know each column will represent. In order to we also convert the column corresponding to the region into a categorical variable in order to tell R that this is not a quantitative but a qualitative variable, and R will model it as such in a linear model. The model here is LM, is the same as we used, the same command as we use for simple linear regression. Again, on the left, we use the response variable. On the right, we use the predictors. But what I did here, I did not write in any predictors, but I put a dot. What that says is that the function is going to take all the columns except sales as being predictors. All the columns in the data, providing the data provided in the function, will be considered as predicting variables. And this is a portion of the summary of the model. And what I'm highlighting here are the estimated regression coefficients, particularly if we want to look at the estimated coefficient for advertising expenditure. Here, the estimated beta is 1.4092. The way we interpret this is the expected additional gain in sales in thousand for 100 additional expenditure and advertisement, while holding all other predictors fixed. A reminder here that the units for sales is thousands, the units for advertising expenditure is 100, so we need to be careful in the interpretation. Also, I'm highlighting here the fact that we need to add the fact that all the other predictors are held fixed when we interpret this coefficient. If we contrast this with the marginal model, if you recall, the estimated regression coefficient was 2.772. So you see that this is larger than the estimated coefficient under conditional model. So the way we interpret this coefficient, this is the expected additional gain in sales in thousand for 100 additional expenditure in advertisement, not accounting for other predicting variables being in a model. So if we want to predict the additional sales for an additional $1,000 in advertisement, $1,000 in advertising expenditures, this is going to be about 14,000 additional sales under the full model and about 27,700 additional sales under the simple linear regression. And we can see that our prediction is very different. So which one is more meaningful? Because sales vary with other factors, the interpretation based on a multiple regression is more meaningful. Under the full model, the estimated variance is 55.57, and this value we can get it from the output. This is the squared residual standard error. Under the simple linear model, the variance estimate was 101.4 square. So what we see here, there is the difference between the two variances is that the variance under the full model, the variance of the errors, estimated variance under the full model is much smaller than the estimated variance under the small model, the model with one predictor. So why would that be the case? The reason is that when we include multiple variables in a model, more variability in the response is explained as compared to the model when we include only one variable. We're now going to look at the different roles that predicting variables take in the second example, where we want to analyze the variation of SAT scores across states with respect to different variables. In this example, we will examine the compositional and demographic variables to examine to what extent this characteristic were tied to SAT scores. The authors of the study of this data noted that the states with high average SAT scores had low percentage of takers. One reason is that these are mostly Midwest states that used to administer other tests to students that went to college, in-state college. Only their best students planning to attend colleges out of state took the SAT exam. As the percentage of takers increase for other states, so does the likelihood that the takers include the lower qualified students. So thus in this study, we have two controlling variables, takers and ranking of those students taking SAT to control for this bias across all the states. All the other variables can be used as explanatory factors. Thus, for example, if we would like to rank states by mean response, by the mean SAT score, we'll need to first control for these two factors. Moreover, if we want to study the impact of the other explanatory factors, again, we need to control for these two factors. In this lesson, we learn how to use our statistical software R to implement multiple linear regression and estimate the regression coefficients and the variance. As well, I illustrated with an example the difference between explanatory and controlling factors. Thank you.